So next up, I'd like to welcome Wayne Harrall from Kent County Road Commission, and he will be talking about local bridge preservation utilizing a county bridge crew.
Michigan, Kent County, I am the managing director of our engineering department. Kent County, I've got it highlighted there. We're kind of on the southwestern part of the state. And really just wanted to show the largest bridge in Michigan, which is something that was built just before I was born, but it was major for economy and tourism to be able to go from the lower peninsula to the upper peninsula of Michigan. The bridge is 5 miles long, so pretty awesome. My bucket list is to somehow get up on top of that thing without getting arrested. Our bridge system, we've got 172 bridges. My numbers are slightly off because you add them all up, it's 173, but it's 163 bridges over water. We have one over a roadway, one over a railroad that is our bridge, and then 7 bridges that are other owners that we do inspect, railroad, pedestrian bridges. And the span lengths are from 20 to our largest bridge, which I had the fortune of being the project engineer on, was a 1/4-mile bridge over the main river that goes through Grand Rapids, the Grand River. Our system, of those 165 bridges, about 100 are culvert-type, earth-filled, either 3-sided, 4-sided, something without a deck. So actual bridges, we've got about 65, or at least what I would consider bridge with foundations and superstructure and decks. And we've got 5 large river systems. The Rogue River, the one up at the north, is on the state natural river system, so we get our DEQ permitting, but we also need permitting from that agency. The one on the Flat River, far to the easterly or the right-hand side of the photo, that is also on a natural river system. The Grand River, the 4 bridges there are our longest bridges. They were 500 to that 1/4-mile bridge, so those are our longest bridges. We do have 3 historic bridges, and this kind of goes toward at least our commitment in our county to try to preserve, try to rehabilitate, and replace when that is really the cost-effective option. Maybe we're widening and it's not practical to rehab or do preventative maintenance. The covered bridge is 148 years old. That concrete rainbow arch is the only one in Michigan, and we don't know if there's another one in the country like it. It did get a state historic designation about 5 years ago. And then the steel, that's 95-year-old bridge, and then the steel camelback truss, which is in the background of this picture, is 94-year-old. And it was actually relocated from Wayne County on the easterly side of the state to this location, 1995. The covered bridge, this is our covered bridge really after we did a rehabilitation, pretty major rehabilitation on it. We did use enhancement funds, so in the brochure it says I'm talking about our county bridge crew. I will do that, but I just wanted to share really, I think, our commitment to preserving what's out there. So this bridge is still open, has a 5-ton posting on it, so vehicles, standard vehicles can go over the bridge. We did have a concrete truck, thanks to Google Maps, that went across here, loaded about 40 tons. And fortunately, they didn't stop in the middle because they shouldn't have been able to make it over this bridge. It's probably load rated, it's probably good for maybe 12 tons. So they were very lucky. This is that rainbow arch. It's a 100-foot span. We did a major rehabilitation in 2014, again with enhancement funding. We cleaned it, we put silane on the sides, we did a bunch of patching, put a microsilica deck overlay on it. And again, part of what we're dealing with these structures is, since they are historic, for us, we'd either have to relocate the bridge, which in this particular case, this photo, Wayne County had a situation where they needed a 5-lane bridge. This no longer met their needs. We had a historic single lane width, two-span bridge, which was historic, and we were able to find a home for ours, and we took their bridge, cleaned it, painted it. That was in '95. In 2015, we did a total sandblast and recoat with enhancement funds on this bridge. This is over that flat river, which is on the natural river system in our county. Our bridge crew. So it's not a large group. We do fairly small things with these guys. When we need cranes, when we need pile drivers, things of that nature, we will work with some of the local contractors, which I'll get to in one of the slides. Vegetation control, just keeping the trees cut down. When you talk about sediment on the bridge seats, I mean, you get vegetation growing on the bridge seats. So cleaning those off. Deck sweeping, we do by contract. We have an annual contract in the spring that will go in and sweep all the bridges that have curb lines. Joint cleaning, that's probably a little more difficult one. Just to spray them out into the river really goes against our stormwater rules for us, so it's a little more manual work. You can do some vacuuming, but that's probably the most important thing that we do, but we probably need to do better. Different waterproofing, it could be a membrane, could be some type of sealer. Epoxy deck seals, we've done most of our bridges with our own people. The quarter-mile long bridge, we did that epoxy overlay with our people. Slope paving repairs and culvert replacements and sometimes repair. This is just an example of a couple fairly new bridges. I was out this summer and, the joints haven't been in there very long and they need to be cleaned out before winter because they just aren't going to function the way that they're supposed to. Waterproofing, we do that in a couple ways. We have a lot of side-by-side box beam bridges. We probably have 30 of them on our system. And I don't know if I know they're very popular to Michigan, very popular to local agencies in Michigan. So we use an activator with a hard membrane sealer, mill those. They typically have an HMA surface on them. So you have the beam, which is the superstructure, is the deck, and you can either have a concrete surface or an asphalt surface. Most of ours have asphalt, and most of them, load rating wise, you couldn't convert them to a concrete deck, so that's something that we try to do on a regular basis, is to mill those off and waterproof. This is that bridge, which is a quarter-mile long over the Grand River. It's on caissons. We chose to build it with similar beam lengths, 10 spans, 125 foot. Wisconsin beams at the time, and the parapet rail was an Oklahoma rail. So when we picked it, we tried to be multi-state on that. But it's a large crossing. It's one of the few crossings on the Grand River that actually is above the 100-year floodplain, which is important for this area. Most of the bridge spans a forested wetland, only 4 spans, so you have 500 feet of 1250 that is over water. The epoxy deck seal, one thing, we've worked with our MDOT bridge crew. Some of our folks worked with them helping seal decks. In the summertime, with the MDOT bridge crew folks would plow snow on our system in the wintertime, so kind of a partnering thing. But the good thing is our people were trained basically by the DOT staff. So again, this is actually putting a epoxy seal on that quarter-mile long bridge with our crew. The sandblasting that we do hire that out. The only thing we do is squeegeeing the epoxy and then putting the sand or the aggregate on top. Probably the biggest concern from an asset management plan are these corrugated metal pipes for us. We have many that are similar to this one, multi-span, over 20 feet from beginning to end. So in Michigan, that's a bridge. I know some areas less than 20 feet. I think Ohio I think you classify it as a bridge less than that. And we have a lot more that are less than 20 feet as well. So back in the day, It was something, I think, that replaced bridges. They were able to put these pipes in between abutments and fill over them. One thing that we are trying to do, and this is actually our bridge crew, get to some of these before they deteriorate, which primarily is right in that water line where the water fluctuates. If you're in high agricultural areas, near golf courses, where you've got a lot of fertilizers, organic material. I mean, we've seen some of these that have lasted 70 years and be in pretty good condition. We've also seen some that are 40 or 45 years old, probably close to their life, that they really just have deterioration in a fairly confined area. So what we actually did here is we attached nuts to the bolts that constructed this galvanized pipe. We put a nut on the outside, added a bolt to that, used that to tie reinforcing steel. So we really created somewhat of a composite bottom and made sure that we poured this sidewall up above where the normal high water would be. Again, just to extend some life. This corrugated pipe is about 45 years old, and we're hoping, we can get another 20 years. The cost for us to do this versus a replacement, probably 25% of the cost. The other thing that we have in Michigan, our DEQ, they really don't want you to put this back. So we're not going to get permission to put back the one with the 3 pipes. They're likely going to want a bridge. We'd rather maintain the pipe if we can. The pre-stressed side-by-side box beams, this is a project we actually did with our crews. In Michigan, we compete for the state and federal money on a basis, all the agencies, 83 county agencies, 450 cities and villages. So all those groups, annually you submit applications in for state funding. This bridge, we submitted a couple years. Because we are one of the bigger counties, we have a higher budget. It's harder for us to get those funds because they do have some financial factors. We didn't get it funded, so we decided we were going to do it our own. With our crew, this is one where we actually talked to a local contractor. They had an idle crane and an idle operator, and they parked the crane here for about a month. During that period, we went span by span. It's a 3-span bridge. Retained the substructure. Substructure was in good condition. We did put some sealer on the caps of the pier. It's the 2 piers. And then we had the operator and one of their laborers just when we were removing and then resetting the new beams. Then we did the grouting. You've got a keyway on these. You grout the keyway. Then they're post-tensioned. So we did put it back the same way that it was before. Again, that bridge was probably 45 years old, which really, our goal is we want to extend that life to the design life. So really for a bridge with a foundation superstructures, 75 years, that's what we designed for. And that's what we would like to get out of them. This project, we used our own funding. We did it pretty economically. Like say the crane was available, they just parked it there. We worked with a trucking company to haul these beams away. We actually, my assistant, who is our bridge engineer, his idea, we took the worst beams, they took them to Lawrence Tech University in Michigan, and they've got a facility there where they could load test them. We also took some of the better beams, and I never saw the results of that. Really, the idea was, hey, let's do some destructive testing. These look terrible. Let's see, what they actually can hold. The metal culverts, we haven't installed one since I've been with the county for 30 years, other than small culverts. In some cases, because of the soils, it's just the right choice. The sinkhole. I hear on the news, well, there's a sinkhole. I always know it's a culvert, or it's a storm sewer, or it's a sanitary sewer. In Michigan, there aren't just random sinkholes that occur. This is one, this is one that's not a bridge. It's less than 20 feet. We do inspect them on a less regular basis. For us, we target about every 5 years. Depending on the water level, when you inspect this, you may or may not see this. But this structure was completely rusted through. It actually broke through, which caused the sinkhole. Our preferred replacement in this case, it was a single pipe for another single culvert, is the four-sided box culvert. I think we get our best bang for our buck, and we've got a lot of them in our county system. And other than some of the peripheral, the slope paving and things like that, we don't do much maintenance on the box culvert. This is another application, one that our crews did with the sheeting. We do rent a vibratory hammer. We do own sheeting for bypass pumping and things of that nature. We also sold to one of our townships, township that I live in, repurposed beams. This was some park property in Grand Rapids Township. They'd bought the property. This was like an old farm crossing, and the stream had migrated. There was an old trailer bed that was there as the bridge, and the stream migrated around it because I think it had brush and things. The bridge that we removed the beams on, and we sent some to Lawrence Tech. We also saved about 25 of those 42-foot beams just for potential things like this, maybe an emergency situation. So the township, these beams were free to them. They paid for the installation. They got a nice pedestrian and an emergency bridge out of it for their park. We had a steel girder replacement. It was a rehab. We removed the steel girders and put in pre-stressed concrete I-beams. Another really good project, but the township wanted a couple of these beams to span a ravine in that same park. And this is not the final picture, but they ended up using a prefab deck for the top. They paid to paint those beams and got a good structure out of it. Couple projects that we recently bid out this year. One was some pretty substantial substructure repair work, was done with shotcrete. We then sprayed silane over all the pier system. Side-by-side box beams on it are in reasonably good shape for the age of the structure, about 45-year-old structure. The culprit of this really was the joints. If we would have taken care of the joints early on, we had about 4 times the amount of removal and replacement repair work on these piers than we had estimated. So we're pretty comfortable that we've got a good repair and that we'll extend the life of that again to its 75-year design life. And this is something new for us. It's a pretty major bridge crossing, crosses over used to be a rail, now it's a trail, and that Rogue River, which is on the natural river system. It's basically going in to replace, bridge has 81 girders on it, these precast box beams. We're replacing about 10 of those. The majority of them are in pretty good condition. Where the water is along the curb line, that's where you typically are seeing the deterioration. So this is a project that's just wrapping up the end of this month. So we're kind of excited about it because we think that will be one ability to go in and replace the beams that are bad, retain what is good. Keeping the water out, keeping the salt out, definitely in our environments that most of us have, is the critical thing. So I think if we can deal with the things on the surface, we're going to extend what's underneath there a long time.
Thank you, Wayne.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.